because of their variable oxidation states and the differing colours which accompany these oxidation states, transition metals are ideal for doing titrations. The one that you're going to see most of is with manganate 7. Now manganate 7 is a lovely deep purple colour, and it acts as an oxidising agent. The manganese itself is reduced to manganese 2+ ions, so the half equation for this, which you'll get used to, is that, and those 5 electrons balance the charge, and that shouldn't be a surprise since the manganese is going from +7 to +2, which is a decrease in 5, and those two numbers will always match up. So the change in oxidation state will be the same as the number of electrons involved in the half equation. Classic thing to do the titration with is iron 2, and we can oxidise iron 2 to iron 3+, and therefore there's just 1 electron there, and so when we put these two together we have 5 electrons in the manganate half equation and just 1 with the iron, so we will need to multiply the iron through by 5. In terms of the colour change that you'll see when using acidified manganate, now in this case we're looking at the conical, and we've said that we've got iron 2 in there, which is very pale green, almost colourless really. Now when we add a drop of our manganate, which is a vibrant purple colour, when it goes into the solution it will oxidise some of the iron 2, get used up, and so disappear. And this continues as the titration proceeds, but at the end point, when we've used up all the iron 2, that last drop of manganate that goes in doesn't get used up. There's no iron 2 left to oxidise, and so spreads out in the solution. So it's effectively like adding 1 drop of Ribena to a glass of water, and the solution goes this pale pinky colour. We've said to put the equation together, we need to multiply the iron through by 5, which means we have manganate and 8 hydrogen ions and 5 Fe2+, goes to Mn2+, and 4 waters and 5 Fe3+. For this simple calculation, first of all we need to work out the moles of manganate that we've got. You can see that we used 20.2 centimetres cubed of fairly dilute 0.02 moles per decimetre cubed solution. So we want 0.02 times 20.2 over 1,000, which comes out to be 4.04 times 10 to the minus 4. In terms of the moles of Fe2+, well, we want to just multiply that through by 5, since they're reacting in a 5:1 ratio, and that gives us 2.02 times 10 to the minus 3. And now for the concentration of the iron 2+, we just want to do the moles divided by the volume. We had a volume of 25 centimetres cubed, so that's 25 over 1,000 that we need to divide it by, and that gives us a concentration of 0.0808, and that's moles per decimetre cubed. the question is asking for the iron sulfate in grams per decimetre cubed. So to go from moles per decimetre cubed into grams per decimetre cubed, basically we're just going from the moles to the mass. So we want to multiply through by the MR. So we have a 55.8, a 32.1 and 4 lots of 16, which should come to 151.9. So multiply that by our concentration in moles per decimetre cubed, and that will give us an answer in grams per decimetre cubed, which should be 12.3. Let's have a look at another example, slightly more open-ended here with not quite as much help for us. I've written the equation at the top of the page. The bit that I'm interested in is just that first part, reminding us that the manganate and the iron 2, which is what we've got in our lawn sand, are reacting in a 1:5 ratio. So that will be part of our calculation. If we have a look at the question, we're told that we've got a certain mass of lawn sand, some of which is iron 2. The question will ask for the percentage by mass of the iron in the weed killer. So to allow us to access that, we've got a volume and the concentration of the manganate that's used. So this is where we'll start our calculation. So the moles of the manganate, concentration times volume, and that's 6 times 10 to the minus 4 moles of manganate. So the moles of iron 2, remember they're reacting in a 5:1 ratio, so we just want to times that through by 5, and that gives us 3 times 10 to the minus 3. We now know the moles of the iron 2, so we can get the mass of the iron 2. Well, really that's just the mass of the iron. So that's going to be the moles times by the relative atomic mass of iron, which is 55.8, and that gives us a mass of 0.167 grams for the iron. And finally, to get the percentage by mass of iron in the weed killer, well, we've got 0.167 grams out of a total mass of 0.588, so we'll just get the percentage by dividing one by the other, and that should give us an answer of 28.5.